Hello, everyone. Welcome back to the hands-on practice on the seismic interpretation, how we can do the seismic interpretation with the real seismic data. So the tool which I'm going to use today to demonstrate the seismic interpretation lab or the task, so which is PaleoScan. It is from Ellis. So if you go into your software when you open it, so you can go into the new project. So just go into the file and click on the new project. So over here you can look at the project directory. So I'm making a project directory with the name as 4, or you can make it paleo interpretations interpretation. So the paleo interpretation, you can select this folder, and over here you can mention the project name. So the project name for this interpretation is F03, and also the CRS is actually your coordinate reference system. So over here you can locate. So if we already know the exactly location or the coordinate system, then you can put that one. But roughly I know this data is from this part. So actually it's from Europe. So you can just put this one for the time being, because we are not exactly knows about the data. So it's UTM. So just put it here. So you can have this location highlighted with this green box. So you can just click OK for this. So it already has the coordinate reference system. So now you can click OK. So it's asking for the previous section to be saved. So I will just put no. Restore the previous section. We don't need the previous section. So now your project already created. So the first task, as I mentioned in our slide, so first we have to do the data loading. So in data loading, we have the 3D seismic, well log, and 3D horizons. So these all things we need to go through and load our seismic data accordingly. So here you can go into the file. You can import your segway. So either you have the 2D line or you have the 3D. So the 3D data will be loaded by volume. So either you have the 3D data. So for this case, we have the 3D data set. So we will choose the volume segway. So from here, you can open your segway file. So the segway file can be loaded. So you can locate your data set. So your seismic data is over here. So we can just open this data set. And the second thing, you can look at the header information. What are the bytes and the location of the byte in your data set. So you can just zoom it in, and normally it will takes from the automatically, but you can check if your byte IDs are not same as the autopic. So for my case, all the things are okay here. So we just put it okay. So it will take some time to load your seismic volumes. So the one of one has been successfully imported. So you can just hit OK. So now here you can look at your seismic data. So either if you want to go up and down, so you can see your inline can be changed from 479, 485. You can just scroll up and down from your mouse to look at the other lines inline. If you want to have the other cross line, so you can just go to the volume manager. So over there you can choose the X line. So the X line also you have to create this volume. So you can just put yes, then it will calculate and take some time to process the X line as well. So here you can see this is your X line. The name is mentioned here, 713. So you can just scroll up and down to look at the other lines. So the another things what you can see in 3D seismic data. So you have the in line and X line. So the other thing you can look at the time slices. So you can go to the volume manager here and click on the time slice. So the time slice you can just put yes. So it will load your time slices as well. So now here time slice is actually 1292 millisecond must be. So you can scroll down or scroll up to look at the feature at each time. The same thing you can look at the 3D seismic 3D display. So you can just display 2D view in 3D. So you have to synchronize 2D viewers to 3D object. You can say yes. So over here you can see. So you can hold the right click and go up and down your mouse so you can zoom in and zoom out. So over here you can look at the different surfaces. So you can see it's going up your time slice. So similar way you can look at the, just double click on here and you can display in 3D. So this is your inline. You can see how does it appear. Then the similar way you can open your X line and you can display in 2D views. So now let me zoom it, maximize this screen. So over here, what you can see your inline, cross line, and time slice. The another things what you can do is you can just okay, so we can zoom it out. So the first task of the project is to load your seismic data. So now we will move to the second task, which is the well log, loading your well logs. So for loading your well logs, so now you can go into the file, same icon, import, and you can go into the well. So from here you can choose your less files, go next, and here you can add your file. So you can go at the location where your well logs are available. So you can choose either one well logs or you can choose either all well logs together. Once you click open, so it will come into your file names or in the well import section. Then you can just click on the import. So over here it's actually giving you the well name. So the well name is F021 and XY location, and also the KB is a Kelly Bushi, and the CRS location you can give if you have all these things. So you can just click OK and it will open the second one, 04, then 01 and 02. So all four well has been created. So you can just hit the finish. So once you have created the well logs or the last file, then you have to go and insert the well heads. So again, you can go to the well, sorry, in import and well. So you can go well heads, go next, and you can add your well heads here. So in the well log data, you will have the well heads as well. So you can open it. Then you can go click on the import. So the configuration is invalid. So you have to go and double click on the wellhead text. So over here you can use the separator option in tabulation. So the table is 1, 2, and 3. So over here you can choose the column to import. So the first column, which is column number 1, is your well name. So the your X is at column number 2, and the Y is column number 3. And KB, obviously it's not given, so we don't choose the KB over here. So you just click OK. Then now it has taken the name. Now you can hit on the import button. So once you import, so it will give you the message, the 4 well updated. So you can just hit the finish button. So over here you can see on your left side, so you can see your well log has been loaded in your data. So this is actually how you can view your log. So you can choose the color bar, which color you want to give. Either you want to choose seismic and a lot of different color scales. So we are not going into detail. So we just look at the well logs. How does it look like? So now when you open it, so let me zoom it in. So over here it shows you delay time, gamma ray, your density, measure depth. So these all location at the well location, it shows you all the information of your well logs. So just close this one. So the well log has been loaded. So the third task for data loading is 3D horizon or either 2D horizon. So for our case, we are going to load 3D. Yeah. So for loading horizon, you must have to go to the file, then import, and go to the horizons. So over here, you can choose the 3D horizons. So you have to click on this folder, open file. So in your data set, you will have the horizons data. So either if you want to have like choose 1 or 2, either you want to choose all, it's up to you. So for my case, I'm choosing all these horizons. So just open it and go next. So all the names of the horizon, which is FSST, HST, LST, and MFS are loaded over here. You can do next. Over here is actually showing you the XY coordinates and each information, like your X in this file is at 1, 2, and 3. So this information is here. Like we have loaded the well. So the horizon also need the X, Y, and your time. And Z or your time. Z either can be time or your depth. So just click OK to load this one. So now it will import one by one. So now it's asking current horizon is not fully included into the reference seismic import. And so actually the horizon is not included into the reference seismic file. So we just say okay, whole horizons. So you will see the horizon will appear. Just click on apply to all. So now the first and second has been uploaded, and third one is going to be done. Now the fourth one. So once it is done, you can open your seismic 2D window. So you can see all of your horizon, which is the first one is blue, light blue, dark blue, yellow, orange, and this one is reddish color. So all the horizon has been loaded into your seismic data. So if you want to look at the 3D viewers, so you can see all of the horizons. Actually, it's 4 horizons. So the first one is blue, then yellow, orange, the reddish. If you want to go into detail, so you can see how this horizon has been integrated. So now the visualization part is already done. So I have shown you 3D data, horizon, and time slices as well. So now we will move into the model grid interpretation. So how we can choose the model grid interpretation for our data set. So for model grid interpretation, so you have to go into this column. So you can choose the model grid. Then you can go into the new. Either you want to do the 2D model grid or 3D. So for our case, we are going to have the 3D model grid. So you can look at this section, focus on that. So actually here we have to give the input parameters. First, we have to choose the input volume, on which volume we are going to apply the model grid. So first we have choose the our volume, which is the seismic F3. So now here we have already choose our seismic volume, which is F03, and here is the patch size. So the patch size, which minimum can be 3, so it's actually the number of bin. And either you can choose which polarity you want to pick. Either you want to have the peak and trough, or you want to have the zero crossing, inflection point, peak, trough, zero crossing, peak, trough, inflection point. So there's a lot of options for you to pick your horizon. So what does it mean? So either you want to, let me see just explain on how we can pick this peak. So once you go here, let me turn on the vehicles. So what does it mean? So if you choose, let me go into the top data set. Yes, over here you can choose, if you're choosing the peak and trough, it's mean you will have one horizon here on the peak and one on the trough. So if you choose the zero crossing, so zero crossing positive or zero crossing negative slope, so either this slope will be interpreted. So for the sake of simplicity, we just go for, let me turn off this wiggles. So over here you can go. So for the sake of simplicity, we just choose the peak and trough. And over here, we can choose the 7 patch size. So also you can have the options, advanced option. So in advanced option, you can choose which method you want to use, either between the horizons. So if you want to choose the between the horizon, so you have, let's say, this and this horizon, you can pick and you can have the in between. But this one I'm going to show in the next step, which is the horizon stack. So this one you can choose the thickness as well as the threshold. So that one is an advanced option, but we just go for this one and test our parameter. So for testing your parameters, you have to go and pick this cursor and click at the certain position. So let's say I want to test my parameter in this area. So when I put this one, this yellow dot will be active. So you can go and click on the test parameter. So it will create the patch computation or the model grid computation in this area. So now you can see all the horizons has been picked in between this area. So either you can go into the inline or you want to look at the X line. So this one also have been picked. So you can see a lot of all the main features which has the zero crossing, not zero, peak and trough has been updated. So over here you can look at the ISO line. So the ISO line is actually showing you the continuity of your reflector. So if you go down, you can see all the ISO line has been showing you. So this thing you can display over here. So where is my ISO line? Even in 3D cube, you can have the display if you have the double screen window. So this one is a ISO line. Then you can open the grid. So grid is actually this one. So when you have so let's say this grid and the whole seismic volume which is selected has been divided into this grid. So if you will reduce the size of grid, it will be more accurate. So the maximum patch size of this grid, you can go up to 3. So let's say if I go for 3 and test my parameter, so you will see this grid will be more closer. So now you can see the grid has been more closer, and a bit more improved interpretation has been done in between. So it's up to your choice. So how much you want to have the grid size, and what thing you can have is up to your choice. And also you can turn on your wiggles here. So to look at how accurate it has been picked. So you see we have chosen the peak and trough. So only the peak and trough has been chosen by this algorithm. So this is your peak, and this is again your trough, peak, trough, peak, trough. So that one you can choose yourself. So all the lithology or the interpretation will be done automatically. So once you're agree with this parameters, so you can just put at the save button, and then you can recheck your parameters. So the patch size I have choose the 7, polarity is peak and trough, the smooth level is 7, inline underline 1, X line undersampling is 1, vertical undersampling is 1, correlation threshold is 0.3. So once you have done this, so you can just put your output volume name. So this is your output volume name, which is smooth 7pt. So we just put OK, so it will create the model grid. So it's depend on your system, how efficient is your system, that much it will take the time. So this is going to be the last step of auto horizon building. So now the process has been done. So now it's updating your model and creating your model grid uh, to your seismic data. So now the message has been come, the model grid has been successfully created. So let me look at the model grid. So over here, if I zoom it in, so over here you can see at the full data set on the 3D cube, it has created the horizon picking. So now you can look at the each and every inline or the cross lines, all 3D data. So now you can scroll up and scroll down to look at the data set. So let me just fit to the screen. So, and here, what you can do if you are interested, let's say on this horizon, so you can again click on the ISO line. So this ISO line, let's say if you're interested in this formation or this formation, then you can just go and rename this one. So let me open this one. This one is over here. So once you, okay, but this one is actually all the name of the formation that you can look at that area. So once you have done this part, so you can have a look on the X line. So this is your X line. All the horizon has been interpreted here. And you can also look at the time slice. So which actually takes some space like 2 GB. So we are not interested right now. So once you have done this thing, so if you want to still edit this interpretation, you can do that. But for the time being, I'm just following this model grid application. So then we can just go for this one. So once you have completed this task, now you can create your model grid. So you can just go and click over here. So geo model creation. So you can click on compute the geo model. So over here you have the horizons, interpolation size, smooth size, and the link probability. So once you are agree with all the parameter, you can just save, and the geo model, which is auto interpreted, will be created with this name. So you can just click OK. So now it will do the process of creating your geo model. This will also take some time. So let me bring you to the finish or the final stage when it has been created. So now here you can see that your model has been created, the model volume computation completed. So for me, it took around 11 to 12 minutes, but it's based on your computational capability. Maybe take the shorter time or the longer time for these data sets. So we just click OK. So the model which has been created, it has been come to the volumes. So it's coming here. So now here you can see your model grid interpretation. So you can see all of your horizons has been interpreted. So now you can move up and down. So this all looks like your lithological columns or your horizons which has been, you don't need to pick one by one. So this is all auto interpretation with based on the help of the uh, grid model grid application. Also, you can go into the model grid, so you can have your initial grid model. If you want to look at here, or you can look at the auto interpretation, so you can have the auto interpretation as well. So the another application which I'm going to show you is about the horizon stack. So in horizon stacks, what we can do is we can look at the either 10 reflectors or 100 reflectors, or it's based on your own interest, how many reflectors you want to pick in between a specific range. So for model grid interpretation, sorry, the horizon stack interpretation, you have to go into this section. So over here, you can choose the horizon stacks, which is the 7th number from the top. So you can choose here, then you can go for new horizon stacks. So we are going for 3D horizon stack. So you just click over here. So let me fit into the screen. So over here, you can choose the input volume. So this is your input volume. Then you can choose also the display volume, which is this one, either here or either the other one. This one you can also choose. So this is the original, this is smooth one. So we just go for the original one. So over here you can see the right, on the your right you have the cursor. So either you can choose the top layer or the bottom layer. So which layer you want to choose, in between you can interpret number of horizon. So let me choose from 0.5 second to 1 second around. So from this top is your green and the base is your blue color. So either you can want to view your horizon, you can just click on here and you can look at the horizon as well. You can change the color as well. So the color, let me choose this reddish color so it will be more visible. I'll go for a lighter color. So this one. So once you zoom it in, so you can see all of horizons can be picked in between. So either you can choose number of horizon is 100 or 10. Let's say, let me choose 10. So it will just choose the 10 horizon in between this window. So that's the beauty of this application, horizon stack creation. So you don't have to pick each and every horizon. So either if you want to pick your 5 horizons, so you can just click and it's based on your fingertips. So you can just go down. Let's say you want to find this structure more closely. So in between, you want to have the 10 horizons or maybe 50. So it's just on your click. So if you want to have the, let me take the 20 horizon. So you can see all 20 horizons can be interpreted in between this from top here to base here. So once you're agree to create these horizons, then you can go to the next from this arrow. You can go here and the another things which I'm going to show is the seismic attribute. So the multi attributes application, how we can apply to our seismic data. So let's say attribute one, which one you want to choose. Let's say I want to choose the RMS amplitude. And here you can give the output like RMS amplitude map. Then the second attribute, which one you want to do is, let me take the sweetness. So you can name sweetness attribute. Then the third attribute which I want to pick is the, let me polarity. Yeah, let me take the polarity attribute. So the polarity. So it is actually very quick and fast. So we, for the time being, we will choose the three attributes. So for obviously attribute, you have the input, which is this one, and the parameter you have to give the volume. So the volume you can choose from here. So this is, you can just drag your volume here. For the second attribute, this volume, then the third attribute, again, you can bring another volumes, the same volumes. So once you are done with this selection, then you can go and run this application, which will take actually the size of 781 megabyte. So altogether, this three. If you don't want this all attributes, you can just remove one. Let's say if I add one, so it's adding your space. So you can just remove one. So how much you are interested to do. So let me just run this attribute application. So this horizon stack is actually creating your attributes. So it is applying for three attributes. So the first one, attribute 1, 2, and 3. So it will do one by one the uh, processing of these all attributes. So now it's starting for the second attribute. So the second attribute, hopefully it will take some time and it will be finished accordingly. Because we are applying to the 3D data set, that's why it's taking a bit more time to calculate the attribute application and apply to the whole 3D seismic. So once it is done, then we can look at inline, cross line, the time slice, or either the horizon of each attribute. See, the third attribute is polarity, so that's why it took less time. So for me, it took like 3 to 4 minutes to apply for all attribute. So now here you can see your attribute studies in the horizon. So we have the polarity, RMS, as well as the sweetness attribute. So now the final task for us is to do the Multibeat attribute application, so which has been done. And now we will look all the data sets. How does it look like? So let me close this window. No. So now you can look at your 3D seismic data. So this 4 we was already have the horizons. So now we will move into the attribute application. Close this one. No. Let me close this one as well. So now I will open the polarity attribute, RMS, as well as the sweetness. So you can see all these attribute can be changed with the different direction. So you have the time slice on different horizons. So at that time, we have choose only the 10, not 10, actually we choose, yeah, 20 horizon. So it's starting from 19. So it's from the top. Let me show this all attribute in 3D window as well. So you can synchronize this all. So you can just select uh, all this attribute here and make it synchronous. Link this attributes. So once you have linked this three window, so now you can move around. So now you're looking at the horizon 14. So how does it look like at this position, and how does it look like? So other thing what I was showing you, so you can open this attribute in 3D display. So yes, you have to synchronize 2D view in 3D object. Yes, over here. So now from here in window, you can go and show in the tile version. So this attribute is actually here, the sweetness. Now you can synchronize this attribute here as well. Yeah, and synchronize this attribute. Yep. So now here you can move all these attributes, and you can see in your 3D seismic display. Actually, you have to look at all attributes separately. So if now you are looking at this one, so if you want to synchronize this one, then you can go this one. And you have the different display of these all attributes. So this one, yeah, here it's showing all three attributes. So the application of attributes are very important for seismic interpretation. So let's say if you have the difficulty to pick the horizons and you are confused with the uh, amplitude decay or the enhancement, then you can just apply the attribute and you can see how beautiful the models you can create. So over here you can see it's an anticlinal structure which actually showing a very nice display in 3D. So over here you can just close your seismic data, so you can go to the volumes on the surfaces map. So yes, I think that's all for this project. So we have successfully finished all the tasks, which is from data loading up to the seismic attributes. Now you can practice by your own and have a look on the details functions of the software. Thank you so much and have a good day. Bye.